All right, height, got to get steeper, got to get closer together. Excuse me. Everybody good? All right, next. What's the key word in these instructions?
Draw.
No.
Distance.
Distance versus time. What's on the horizontal? Time. What's over here? Distance. Everybody okay so far? At 0 time, when you were sitting at the starting line, how far have you traveled? 0, so you can start right in the corner. Right? If you run at a constant pace, what kind of line will you draw? A perfectly straight diagonal line. If you run very quickly, what will that line look like? Very steep. If you run very slowly, what will that line look like? It will be significantly less steep. If you run it like a race, what will it look like? How do you run a race? Fast, so it's going to start steep, and what do you like to have at the end? A finishing kick. So at the somewhere near the end, what are you going to do with your line? It should get steeper, right? Everybody with me? I don't care how you draw your line. The point is, where does the line end? At 400. Does it ever go back down to here? Why? Because it's distance. So if I'm running this race, this is what it looks like. Start, maintain a constant pace, and then strong finish. That's the way my graph would look. Does everybody understand? Does everybody understand why it ends at 400 and does not go back to 0? Did anybody draw it right the first time? Sweet. That makes a math teacher happy. Uh-oh. Number 7. What's different? Displacement versus time. So what must I remember?
To displace.
It is how far I am from the starting line, correct? What shape is a track?
It's an oval.
Circle?
It's an oval.
It's an oval. Right? There's the middle. If I start here, what happens to my distances? Can it be a straight line? No. Where must I end up? Back at 0. What's it going to look like in between? As I run this way, what is happening to my displacement? I'm going away from my starting point. So where does the line go?
Away from the...
Up.
Yeah.
What happens when I turn this corner? That's a quarter of the way around the track. What is that for my starting line? Assume my starting line is actually right in the middle. What is that? Quarter of the way around. But since it's an oval, what side's longer, horizontal or vertical? Horizontal. So this point right here is what? Approaching the furthest away I can be, yes? Agreed? What happens when I turn that corner? I'm getting closer to home, aren't I? Because the actual distance is starting to shorten. So what must my graph look like? I got to go down a bit. Do I go all the way back down to the start? No, because here I'm halfway, yeah? So halfway through my time, I'm as close as I'm going to get, aren't I? But I'm not back where I started. Am I? What starts happening when I get to halfway?
Keep on going.
It starts to go back up because I'm getting further away again, aren't I? Now, if I maintain a constant speed, these two curves should look exactly the same, shouldn't they? Right? And then what happens when I come around this corner? I'm getting closer to home. Where do I end? Home. Everybody understand? I bet that's the fewest people that drew it right. Does everybody see why? Yes, it's the McDonald's of running. Everybody cool? He's loving it. Michaela, give him a break. Who wouldn't love math? Is everybody cool? Does everybody understand why they did wrong and what they did right? All right, now, number 8, is that going to look the same for any of you? Think about this room. Think about this room. Think about what you know about your peers. Are there any two graphs in this room that are going to be exactly the same? Whose? Probably Mirren and Jemra, because they came from the same house. But otherwise, anyone's going to be the same? No, unless you live in the same house and take the same way to school. Right? Now, what's the key word in the instructions? What's position? Is that distance or is it displacement? Which is it? Displacement? Yeah, why? Because it's a position. Where am I right now? So what position would that be on a graph? 0. What if I move to your people's left? What position would I be? So would that be positive or negative? Negative for you guys. What would it be for me?
Positive.
Positive. Good. Brilliant. So everybody's graph is going to be different, yeah? But the key is this part. Where will your graph end? Will it end up here or back here? A or B?
A.
Why?
Because you're not home.
Because you're not home. So everybody's going to be slightly different, yeah? Mine, I leave home nice and slow on my motorcycle. Then I stop at a stop sign. Then I go a little further. And then I get to a part of the road where I can go a little bit faster. So I steepen up. Then there's a stop sign. Then there's another fast part. Then there's a stop sign. Then I'm on the highway. So what does my line look like? Very steep, covering a lot of position in how much time? Very little. I'm on the highway. I'm flying down the highway, yeah? Then what happens? Then I hit Abbotsford. I almost come to a complete stop at the roundabout, so it's a little line. Lots of time passes. Then I'm back on the road. Then I'm at school. That's what mine would look like. If you walk to school, you going to have any steep lines?
No.
No. Even if you run, you going to have as steep a line as me?
Not as steep.
Why?
Because you're not going as fast.
Because you're not going as fast. I'm going 140. You're not running 140 kilometers an hour.
I can break 30.
Yes, that is pretty much top speed for most people for a short distance. So did everybody draw this one right?
Yeah.
What's the mistake you're going to make? You're going to forget that it's got to end up there. Is everybody cool? Everyone is Gouda? Everyone can draw graphs?
Yeah.
So I can move on? All right, now listen. I'm not gonna... You got some practice in your book. 281 and 295, but we're not going to stop right now. Because the next thing I want to talk about is we're just going to use it. Then we're going to stop. Okay? What was the next thing? Linear relations, yes? Okay. So, turn the page over. Discrete and continuous data. Or data, depending on where you live.
Data.
Americans like to say data. British people like to say data.
It's from Star Trek.
No, it isn't. The android on Star Trek was named Data.
Yeah.
It's not the word for information. That's his name.
But he was pretty smart.
Yes, he was. There was the one episode, that one season where they had the horrible other doctor, Dr. Pulaski, and she called Data on the first episode, and it got him angry. I didn't like Dr. Pulaski, mostly because I had a crush on Dr. Crusher, which was an interesting, ironic name, yes. Dr. Crusher. And the other thing that was weird about Dr. Crusher is in the first season, Dr. Crusher was not super hot. Second season, not super hot. Then she went away for a season, then she came back smoking hot. I think she probably got a little work done in the off season, but I don't know. She was way prettier than Counselor Troy and Tasha Yar. Those two can hit the road.
Star Trek.
Star Trek, The Next Generation.
Galaxy Far Far Away.
Tea, Earl Grey, hot. No.
You said Galaxy Far Far Away.
Yes, I know. I'm going to stab him in the eye for doing the Star Trek Star Wars mix-up. All right, here we go. I'm not really going to stab anyone in the eye.
I will. I am your father.
Prosper and live long. All right, here we go. Graph that.
I'm actually disappointed.
Remember, graph it lightly in pencil in case you do it wrong. It's a special kind of function of which you have seen once. What? I'm sure it was uproariously funny. You guys should be able to graph that. Like I say, it's a special kind of function. You've seen it once or twice. I'll be interested to see. What I don't see is people flipping backwards into the kinds of functions that I've shown them, because the answer lives in your notes somewhere.
Is budget a person or budget like as in like?
Budget is rent-a-car.
Okay.
No, that's budget breaking muffler. Budget breaking muffler.
It's auto centers now.
No, it isn't. They're
What?
different.
They
They're
changed
different
it?
companies. Oh my good gravy.
It's like we know cars, budget, auto center.
No,
it's
that's not it. That's the budget breaking muffler song.
Starbucks. Ask your doctor about it. It's right for you.
I'm confused. I thought they changed.
No.
I'm gonna look this up after.
Well, maybe budget breaking mufflers become budget auto
I
centers.
think they did, but it says budget auto centers, and then below it says brake and muffler. Because
Yeah.
they do more than.
Because they do more than brakes and mufflers now. Yes, they do.
It's like auto.
And people say advertising doesn't work. Okay, even if you don't know what you're doing, you should know how to at least set up this graph, yes?
Time.
What's on the bottom?
Time.
Okay, is it enough to say time?
By day.
Yeah, you gotta have days. 1, 2, how many days do you need? 7. Why can you stop at 7?
It's a week.
Because this data is only good for a week. We don't know what happens after 7 days, do we?
The world ends.
No. The world is not going to end. As is evidenced by the fact that it's now 2015 and all those crazy people that thought 2012 was the end of the world because they based it on a calendar of a people that don't count the same way we do.
The scientists have found a meteorite that's going towards the Earth.
Yes, there's a billion meteorites heading towards the Earth, but they aren't meteorites yet until they get to the atmosphere.
Yeah.
Right now, the Earth is being struck by meteorites as we speak. Notice that nothing is happening.
Yeah, nothing is happening.
At some point, the Earth will be hit by a gigantic piece of space junk. It's happened millions of times in our history.
Scientists have predicted
Life has always gotten along. Different life, but life has always gotten along.
Yeah, if the world blows up, there's people in space.
Okay.
Yeah.
What goes up the side?
Money.
Cost. Okay. How much does it cost me to rent the car for up to 1 day? $65. Is it going to cost me anything if I walk in the door but do not rent the car? No. So at 65 and 0, what kind of dot must I have? Open. Because if I don't take the car, I don't pay. If I take the car, I sign on the dotted line. 1 second after I sign on the dotted line, how much am I paying for that car? $65. For how long? 1 day. What kind of dot do I need in 1 day? Close. $65. What if I keep it for 24 hours and point 0.000000000000000000001 hours? Then how much do I pay? How much?
Still $65.
65 more dollars. So how much will I pay them? 130. At 1 day, is this an open or a closed dot? Closed, because 1 day is still 65. Other way around, open. Once I go past that, I am at 130, correct? What happens at the second day to the third day? Same thing, but what am I at? What am I at? 195. What happens at the third day? Does my format change?
Yes.
Format? No. It's still an open dot. What changes?
Money.
Money, because I'm not going up by 65 anymore. What am I going up by?
30.
30. So this one's going to be a 225, yeah? To 4, and so on and so on and so on. Is everybody cool? Is it a function? Is it a function? It's a yes or no question. Is it a function? Yes. Why? Each input has its own output, even here. Why? Because that point doesn't exist, does it? Only that point exists. Everybody cool? What's the name of that special function?
That function.
Now, let's do some arguing. Should these points be connected? Should this line in red exist?
No.
Why?
One's open, one's closed.
One's open, one's closed. Can't connect them, right?
Yes.
There's no fraction, there's no input for that output, is there? No input, I forgot the N, no output for this output, which it should be output, but I just wanted to keep it going. Everybody with me? So, no for the vertical connectors. Why? Because there's no outputs for those inputs. The output for one day exists down here. It does not exist up here, so we cannot connect it. Everybody understand? Okay. Now, what about the horizontal? Are these lines necessary? Why? Why? Kale. Time keeps moving. It is always measurable. We may not have a name for it, right? There's seconds, centiseconds, milliseconds, nanoseconds, picoseconds, and it'll go down, down, down. But eventually we run out of names. But there's still a time there, isn't there? Right? Because time is always on. Now, let me ask you this. If time is always on, then wouldn't Alon's paycheck be a continuous line? What do you get paid now, Alon? How much?
Minimum wage.
Which is what? I don't know. I haven't worked minimum wage since I was like your age. 10.45? So, shouldn't Alon's graph of his time, 10.45, shouldn't it be a straight line? If time is always on? Yes or no? Why? Because he doesn't get paid per second. He gets paid in, at best, quarter hours, yes? So how many dots would there be between 0 and 1 if we were doing Alon's pay? 4. Why?
Quarter.
Quarter hours. If he doesn't work, he's not paid. If he works quarter of an hour, he's paid. If he works half an hour, he's paid. If he works 3/4 of an hour, he's paid. Everyone understand? What if he works 37 minutes? How much do you think they're going to pay him? Half hour. They're going to round down because they're horrible. If he works 43 minutes, they're probably still going to round down because he probably has a computer that keeps track of when he comes and goes. Everybody understand? Can't be a straight line. Why? Because there's no inputs, there's no output because there's no input for everything between 0 and 15. Everyone got it? So, back to this. Time is always on. Why then is time always on in this case? Someone should be able to explain that to me. Noah? Or are you just exercising your finger like that old campfire song? Do you know that campfire song?
The worm?
No.
I know.
It's a song about a kid who's got a finger, it was so, and his finger, it would go, and his finger, it would go, 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 go. And then later on, there's other actions, but you got to keep doing the finger.
Oh yeah.
And then there's like, you got to do this while you're doing this. It's pretty funny when 30 people are doing it around a campfire.
I know the song where you gotta push that button with one hand and then you push the button with the other hand.
Oh, that's a different song. I don't know that one. Anyway, why is that? Why, if in Alon's case we can't do a line, we have to do 4 dots, but in this case we can do a line? George. Yeah, you're paying $65 for the whole day, no matter how long you take it. So even if we had a name for every fraction of time possible, we'd still be paying $65. It doesn't change. Understand? So first of all, is it a function? Yes. Why? Because there's one output for any given input. For how long? 7 days. Right? So that is where domain and range becomes important, doesn't it? Because can we assume this will carry on past 7 days? We can't. Why? Because we have no data. So domain is important now. What is the domain? And I want these in set and interval, if possible. So I'll have my domain in blue. What is my domain? In set and interval. What's the lowest amount of time I can rent this vehicle for?
1 day. No, 0.
0. I can walk in the door and say I'm not happy with your prices, I'm leaving. So will I ever actually rent a vehicle for 0? No. So it must be less than, yes? Can't be an equals to. Because if I rent a vehicle for 0 days, I haven't actually rented a vehicle, have I? Days. What's the maximum? Can I rent the vehicle for 7 days? So is there an equal sign? Yes. Now put that. What kind of bracket? Round. 0. What kind of bracket? Square. Are there any restrictions on that?
Yeah, I think so. No.
Can I rent the vehicle for any portion of time between 0 and 7 days?
Yes.
Yes, I can bring it back at any time. So are there any restrictions? No. So time can be any number, rational or not. Can I, if I was a science mathy nerd, can I go in and say to the cashier, I'd like to rent this vehicle for the route of 2 days? Could you do that? Yes, because it's 1.414, blah, 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 and you would pay $130. Got it? So I can have any input, so there's no restriction there, is there? What's the range? Zero. Then what? Notice how I'm not even showing you the graph. You can see the graph. What's the next available range value? 65. There's nothing in between, is there? So can we do a greater than less than situation? No, because I'm going to pay 0, or I'm going to pay 65, or I'm going to pay 130, or I'm going to pay 195, or I'm going to pay 225, or I'm going to pay 255, or I'm going to pay 285, and finally 315. Can I do a set there? Can I do set notation? I've already done it. Can I do interval notation? Why? Because there's no interval. Those are the only options allowed for range. Right? Can I pay $307? No. Because I would have taken it for that extra day. I would have had to pay $315. Everyone understand? Yeah? Everyone's got it? Okay. So now you should be able to come up with a definition here. Which of these, domain or range, do you think is discrete? And which one do you think is continuous?
Range is discrete.
Range is discrete. Okay. Why?
Because there's no less than, and it's a line, and there's commas. It just makes sense.
It just makes sense. Okay. I'll try to go a little further with that. Parveen.
Range is discrete because it's specifically change group and it's not really higher.
Okay, you're getting warmer. Yeah, I like what you're saying. Slightly more complex than it just makes sense.
It's like continuous is like a line.
Continuous would have to make a line, wouldn't it?
Yeah. And discrete is obviously not continuous, and there's like dots there, so it's not a line. It's just
Okay. So would Alon's pay be continuous or discrete?
It'd be discrete
Why?
because he's getting paid by not seconds.
Not by a continuous amount of time.
Yes.
All right, there we go. Now we're on the right track. So discrete data. Wake up. The graph does not make a connected line. That's if I have a picture. What if I don't have the picture? Then I have to think fractional inputs or outputs cannot occur. If you don't get fractions, you don't have continuous data. Understand? Okay? If we were graphing the amount of people in this room, would it be discrete or continuous?
Discrete. Because people are not here all the time, continuously.
But there's still the same amount of people in the class.
But if you decided to leave the classroom, it would not be a line. It would just be a dot.
Absolutely correct, Noah. Can half a person leave the classroom? No. It's kind of like saying I have a half-brother at home, an arm and a leg. Right? Or the average amount of children in a Canadian family is 2.4 children. I haven't seen a lot of families where they're strapping 0.4 of a child into his car seat. Does everyone understand? Everybody cool? Everybody good? Now, wait for it. Wait for it. Now I'm going to graph the temperature in this room against the time. Would that be continuous?
Yes.
Why?
Because you're going to have a fraction of a temperature.
Is this a time right now?
Yes.
Does this room have a temperature?
Yes.
Still?
Yes.
Still?
Yes.
Still?
Yes.
Still?
No.
Still?
Yes.
Still?
Yes.
Still? Still? Does the room always have a temperature?
Yes.
Can that temperature move any fraction of a degree?
Yes.
Yes. Can we necessarily measure it? No, but it can be put on a graph. Now, right now there's 31 of us in here. If Noah leaves, what will happen to that graph? it will go down to 30. In the time it takes Noah to leave, once he leaves the room, how many people are in the room now? 30 instead of 31. Is there any point when there is any number of people in the room between 30 and 31? No. Because once he leaves the room, he's gone. Everybody got it? Somebody always says, well, what if he just sticks his hand out the door? He hasn't left the room. What if he just leaves a toe in the room? He hasn't left the room. Don't be lawyers, okay? Continuous data. The graph makes a connected line. If you have the picture. What does it mean in math? Inputs and outputs both exist for all values. Everybody cool? All right, turn the page over. There's 4 questions here. Talk to your neighbor. Figure out the DV, the IV, and discrete continuous with an explanation. When you are done that, then go to your textbook and start on 281 and 295.
Number 1, it just makes sense. Number 2,
Yes. It just makes sense is never the right answer for a definition.
But it just makes sense.
But no. Because humans don't care about whether or not something makes sense.
Math makes sense.
That's why.
Yes, math does make sense.
And religion.
Yes, but whether science is involved or not has nothing to do with it, Noah. Plenty of times in our world do people have beliefs that make no sense.
That's why we're all gullible.
And they still believe it. And that's okay. They're allowed to. But you can't say, this is true because it's true.
It just makes sense.
It just makes sense. Right? What makes sense is that the earth is flat. Because when I look out, it's flat. Is it? No. Right? You can't say it just makes sense. You got everything. Do what you need to do, Jinwan. Yes. That is what you need to do. Please do it.
What if you... Oh, wait, no. Let's do this, Noah.
Yes.
Is vitamin C related to female's age? She's still aging, even if she doesn't take vitamin C.
Good point.
So what's the IV?
Age.
There you go.
Gotcha, Noah.
So I know some people that don't.
And yeah, I mean, somehow get it in your day is most likely.
Go outside? No. Stay inside, sleep in.
Some orange juice. Very little doses. But
And it's discrete.
yes, it would be discrete.
We would measure age in years.
Yep.
I knew that.
Does anybody need number 2 explained to them?
No, sir.
Does anybody need number 2 explained?
Purchase related to the cost.
Why is
Like you're always gonna have the juice rate.
why does
No. You're gonna.
Okay.
You're always.
Are you taking vitamin C right now? Do you have an age?
Yes.
That's why.
It still has a cost.
If you were to go take vitamin C, Michaela, I gave you a bottle of vitamin C pills. Would you just... Would you?
Even if you're not buying it.
No. How do you know how much to take? You look on the instructions,
So it's IV is cost.
right? What's the age?
It's easy as cans of juice.
Everybody cool?
Yeah.
Anastasia, do you got it? You understand?
So
Okay.
it would be
George.
No. Because you can't buy fraction.
Of course, it's a step function. There's always an input, and there's always an output, no matter what.
This one is continuous. Okay. We add it.
But this is discrete here because you take one pill if you're this age, then you take 2 pills if you're this age, then 3 pills, you don't connect the line because you would never take 1.75 pills.
Well, the higher you go, the colder it gets.
Now,
It's still a temperature.
cans and cost.
You can control the temperature.
DV, cost. IV, cans, and it is discrete.
We read that one.
You cannot buy half a can. You cannot go to Safeway and say, I'm only a little bit thirsty. Can I buy half a can of Coke? I'll give you back the rest. Although Coke is smart. Coke has made pop in smaller cans and they charge you more for it. And you suckers buy it. I do not understand it. Those baby cans, 237 milliliters, and they cost more. It's less materials, it's less pop, but we pay more for the convenience. Durr. But,
Fit in your pockets.
now, why is it like this? You go into the store to buy a can of orange juice.
Yes.
The orange juice is all sold out. Was there any cost?
No.
No. You cannot have a cost until you pick up a can of orange juice and actually buy it. Do you understand?
Yeah.
Because you can only count 2 things, right? If I buy 6 cans of soup, would that be on this graph? No, because this graph is juice and cost. I have no cost until I buy juice. I can be in the store forever. I can walk around, fill up a whole shopping cart, leave it, and walk out. That's a little fun prank. Don't do that. It's lame. And finally, altitude is related to temperature.
Yes.
DV and IV.
Yes, it is.
Of course it is. You guys know it's colder on the top of Mount Everest than it is down here. But that doesn't explain DV and IV. DV is the temp. Why?
As you go up, it gets cold. You can control the temperature.
As you go higher or lower, the temperature changes.
Yeah.
I'll get it. Now, this is a tough one. It is, what is it?
Continuous.
It's continuous, but why?
Because you're always going to go down.
Always temperature.
Always temperature.
I do.
There's always an altitude.
He can. Okay, but come on to the office. I don't know. I don't make these decisions. You probably should take yourself though, because class is over in 7 minutes. It is continuous. Why?
Because you can always go up and down.
You can always go up and down in altitude, and you're going to have a temperature. You are not teleporting to the top of Mount Everest. You had to pass through every altitude between sea level, and the top of Mount Everest, 8,848 meters. You passed through every point. At every point, was there a temperature?
Yeah.
Yes. Do you have data for every single point? No. So when you graph it, you have to do dots. But you get to connect them because it's continuous. Does everybody understand that?
Yes.
Your data is always discrete because you cannot measure something constantly. That's why you have to know what it actually means. Do you understand? Right? There's no way to measure something constantly because you can't write it down constantly. You can only write it down in points, but you know that in between those points it does exist. So let me ask you this. On a graph, is it ever going to be an exact answer if you are between points? No. This is technically an estimate, isn't it? Right? Because I don't have a data point for that. Got it? Okay.
Good.